We're looking at applications in terms of its energy value as an alternative to fossil fuels.
As our awareness of what was occurring to our environment grew, we began to build wastewater treatment plants.
The artists wanted people to make the connection between sewage and water.
Hi, I'm Dagmar Timmer. And I'm Vanessa Timmer, and this is The Sustainable Region. Today we're looking at a subject that starts right here at home for each and every person in Metro Vancouver: liquid waste. Well, it's a subject many people would perhaps rather avoid. Sewage isn't sexy, but managing how we deal with our liquid waste is vital to the health of the 2 million people who live here, as well as our region's ecological health. First up in today's episode, we look at changing perceptions around waste. Increasingly, liquid waste is being seen not as something to get rid of, but rather as a resource. This sewage wet well in Burnaby is one of 500 pumping stations where sewage collects before it's pumped towards the closest wastewater treatment plant. You're looking at what's flushed down millions of toilets in Metro Vancouver every day. But believe it or not, this nasty-looking stuff is actually rich in resources.
Your washroom has a lot to do with fertilizer because that's where a lot of that food that was grown and the materials that you consumed end up.
It contains precious phosphorus, a mineral the world is running out of that's essential to agriculture.
There's a lot of nutrients and there's lots of phosphorus in that wastewater, and if we can find a way to recover that nutrient, then it's available for reuse, and that's exactly what our technology can do, is to turn it into a product again that can be used for growing things.
Treating sewage also produces methane gas, which is used to generate electricity in all 5 of Metro's treatment plants.
Sludge is fed into the digester. It's heated and mixed and stays in the digester for approximately 20 days, and the gas is generated. We use that gas to supply power for our treatment process.
And wastewater is warm year-round, offering heat that can be extracted to warm our homes. This recent technology is being used in new housing developments, like the Olympic Village in southeast False Creek, which also features a park that uses stormwater for irrigation.
So basically the way it works, we get rainfall. In the Olympic Village, the water's collected, comes through a series of pipes, then gets to the end of the park, and we have a pump station pumps the water back, because it's not always going to be raining, so we can't expect it to be continually filling. So we keep the pond full that way, and the water is filtered by the plants, natural filtration system.
And another innovation. In most of Metro Vancouver, we flush our toilets with high-quality drinking water. But in the new development at False Creek, the toilets use reclaimed water, and that is the way of the future.
The Metro Vancouver board has now made a commitment to looking at what we call this integrated resource recovery application in all areas of the region. When these new areas get developed, we can use some of these new resources.
At Anasis Island, the plant uses a secondary treatment process. But the water it produces goes through a third treatment and is used to help operate the plant and irrigate the plant's landscaping. Nutrifor is another byproduct of the treatment system. Solids extracted from liquid waste eventually become a soil supplement that can be reused. It's currently being utilized in combination with used preload sand and local sawdust to create topsoil for Metro's new Sustainability Academy, also located on Anasis Island.
Metro Vancouver's goal is to sustainably use all of the biosolids that are generated in the region, and this is an excellent example of that in fabricating our soils for use at the facility here.
But eventually, Metro Vancouver hopes these biosolids can be used to generate power.
We're looking at applications in terms of Nutrifor for its energy value, looking at how it can be further dried and maybe used as an alternative to fossil fuels.
We used to think of waste as something to get rid of, but we're learning it doesn't have to be that way.
Going forward here in the coming decades, in our liquid waste systems, our drinking water systems, our solid waste systems. It's important that we understand how they can be valued for material recovery and for energy recovery.
This relatively new concept is already becoming a reality in a world where waste is no longer worthless. In fact, it's proving to be quite valuable, either as a commodity or to offset our reliance on fossil fuels. In the future, it's hoped this new mindset will become the norm. When it comes to pollution, every home is waterfront property. When it comes to runoff, every storm drain and ditch run directly into rivers, streams, or oceans. Runoff can carry a nasty stew of chemicals, from pesticides to soap, oil, and other car droppings. Never dump toxic material into a storm drain because the storm drain is a direct link to your nearest waterway. And our waterways are only as good as what's in them. Welcome back to the Sustainable Region and our look at liquid waste. Every year, 440 billion liters of wastewater flow into one of 5 wastewater treatment plants. It's enough to fill BC Place 210 times, and that's a lot of flushes. Bathwater is also part of the system, and where we are, it goes to the Lionsgate Treatment Plant, Metro Vancouver's oldest facility, and one of only 2 primary treatment plants in the region. It separates solids from water in a fairly simple way. This is the Lionsgate Wastewater Treatment Plant in West Vancouver. Wastewater treated here comes from the City of West Vancouver and the City and District of North Vancouver. An upgrade of the facility is in the works to incorporate secondary treatment, but for now, this plant uses a type of treatment called primary process.
The whole purpose of this plant is to separate the solids from the liquid. Being screened out are your, toilet paper, any kind of rags that end up in the sewer, lots of organic matter, anything from a garburator, so you've got all kinds of vegetation, waste material. Once it's screened, it gets pumped up to the aerated tanks, which their sole purpose is to settle out grit and sand, which is material that's going to damage downstream equipment.
This is the sedimentation tanks, we call it, and this is really where the primary treatment is taking place, being removal of settleable and floatable solids. These long boards you see moving along the surface of the water we call flights. It's skimming the surface of the scum, the floatables. It does a loop at the end on a chain, and now it scrapes the floor on the bottom of the tank.
At this point, the waste and the water take 2 different paths. The collected waste, called sludge, is sent to a digester.
The digester is heated to 55 degrees Celsius. Microorganisms will feed on this raw sludge and break it down to a safer level.
Methane is a byproduct of the digestion process, and it is used on site to power pumps and the digester boiler. The sludge, meanwhile, is sent to a centrifuge for dewatering.
Polymer is added to this. The polymer will get the solids to kind of group together, and the solids come out of the machine and are loaded onto trucks. That's biosolid, we call it. It's a very good fertilizer being used in that sort of application.
Back across the almost 4-hectare site, the gravity-powered wastewater flow continues with water quality testing.
We have 24-hour composite sampling, both on the influent and the effluent of the plant, and we analyze the 2, and there's our removals right there. We can remove 60 to 70% of the suspended solids, and typically we remove about 30% of the BOD.
BOD stands for biochemical oxygen demand, which measures the amount of oxygen that microorganisms remove from the water. It's important because fish and plants need that oxygen too. During the summer recreation months, chlorine is added to remove residual pathogens. Then the chlorine is also removed.
At this point is the end of the treatment plant process, and out it goes to the outfall in this direction where it's diffused into the receiving waters.
Hi, I'm Candace, and I live here in Metro Vancouver. There's more than 2 million of us living here in the region, and together we throw out 360 million bags of garbage each year. That's around 156 bags of garbage each. This is my share. Watch your waste.
Welcome back. Private sewers connect homes and businesses to the municipal regional sewer network. In our next story, we take a look at the network of municipal pipes, trunk sewers, pumping stations, and wastewater treatment plants that make up Metro Vancouver's sewer system. It's the jewel of the West Coast, with well over 2 million people living in the 24 municipalities and local authorities that make up Metro Vancouver. In a landscape of such beauty, it's hard to believe that it was not that long ago that our sewage was discharged directly into the environment, without any treatment at all.
Up until the mid-60s and late 60s, all of the sewage was discharged to rivers and English Bay and Burrard Inlet and into the Fraser River. And as the population grew and our awareness of what was occurring to our environment grew, we began to build wastewater treatment plants.
There are 5 treatment plants providing service to the region. Metro is divided into 4 drainage areas that operate as separate businesses, billing the municipalities for how much sewage they produce.
The green area all flows into Annacis Island, which is located here. The purple area is essentially Richmond, flows into this wastewater treatment plant down here, Lulu Island Wastewater Treatment Plant. We have the Iona Wastewater Treatment Plant here, which takes all the flow for the brown area, and this mustard color area on the North Shore all flows into the Lionsgate Wastewater Treatment Plant. This map will give you a sense of how much pipe there is actually under the ground. We're responsible for the major red lines, or the major collection system. The major blue lines are major municipal lines, and all the other turquoise lines underneath that are all the municipal lines that are down every street within our region. I'm going to say this is my house right here. When I flush the toilet, the sewage flows down this part of the line, up to this street, and into this major municipal sewer. The flow will continue along this major municipal line, into our Metro Vancouver line, and continue on down to Annacis Island Wastewater Treatment Plant.
The everyday effort that goes into developing the policies and the plans for the wastewater system, for engineering the projects and constructing them that make improvements to the system or expand the system to accommodate growth, and the number of staff that go into operating and maintaining that system is in the hundreds. I would say about half of the effort that goes on a daily basis across something like 800 to 900 staff is towards managing the wastewater system. It's a multi-million-dollar operation.
And a complex operation. First, the geography, a terrain that's hilly enough to require a large network of pumping stations to deliver sewage uphill to the treatment plants. 20 of them owned and operated by Metro, and almost 500 more run by the municipalities. Then there's the weather. In many older areas, stormwater goes into the same pipes that carry sewage. In newer areas, the two are separated. But with so many pipes running underground, it's impossible to catch all the cracks.
When it rains heavily, as it does in Vancouver fairly often, we see huge increases in the amount of water that gets moved down towards the wastewater treatment plant. That's water we don't want to treat. That's water that should be returned to the ground where it falls, wherever possible. And it shouldn't be entering our system.
That abundance of water has led to a system where our reservoirs struggle to provide enough water to the region year-round. Yet when we head into the bathroom, it's high-quality drinking water that we use to flush our toilets. Metro Vancouver is already working on separating the very dirty wastewater from the slightly dirty wastewater, which could be reused for irrigation or as a source of heat, something that's already happening in newer developments. More advances are underway, and Metro engineers hope the public can see the value in the region's sewer system, despite the fact that most of it is buried underground.
I think everybody should have a little more interest in what happens to that fluid when they flush it down the toilet or pull the plug on the sink. There's a very complex process for not only moving that fluid down towards the wastewater treatment plants, but then treating it and making it as inert as possible so that it can be returned to the environment in a way that doesn't damage the environment. Without that system there, it would be an awful place to live. And it's so important to the sustainability of this region to have this system working well and doing what it's intended to do as best it can. And we all, every last one of us, rely on that system being there and functioning in a way that is a benefit to us all and doesn't harm the environment.
Welcome back to the Sustainable Region and our look at Metro Vancouver's sewage system. Did you know that there are over 15,000 kilometers of pipes underground in Metro Vancouver? And that these would stretch end to end across Canada and back? Well, that's a lot of sewer pipes, and they're connected to 500 stations that pump sewage uphill until gravity can send it to one of our 5 treatment plants. The newest of these is located in historic Gastown, and its design and planning is quite the story. The Columbia Street Pump Station stands at the corner of Columbia and Alexander, 2 of the most historic streets in Vancouver. In the early stages of the new station's construction, an old photo provided the clue that the abandoned Mexican restaurant that stood here had historic significance.
One of the local residents around here found a picture from 1911, and he said, "I think that taco shack is this 1911 building." So they realized it was, or probably. So then they stopped the entire project.
The downtown east side is a very active community and a caring community. So a number of people found out, got wind of what was going to happen, and they felt like there was not going to be public consultation.
In response to the residents' concerns, the City of Vancouver, in conjunction with Metro Vancouver, put into place a lengthy consultation process that involved a local historian.
Of course, all this wood and the beams is all first growth Douglas fir, you know, those 1,000-year-old trees I was telling you about.
Bruce McDonald researched the decrepit old building and conducted tours, allowing anyone who was interested to see the sad remains of a piece of Vancouver history. Some of the original bricks were set aside to be incorporated into the eventual design.
For the present, we give you today's reality.
At the start of the planning stage, the city hired an artist to design a public art project, featuring a scale model of a signal tower, the kind that used to communicate with the trains in the adjacent rail yard before technology made them obsolete.
The signal box is sort of like a metaphor for understanding that we need to send signals to the future as to how we're going to build our cities, how we're going to have things constructed.
Incorporating public art is another first for Metro Vancouver.
Quite often public art comes in at the end. I was right here at the very beginning watching everything go up. And it was meaningful because I felt that it's really important to future generations as to what happens with our water.
The installation's theme is connections.
So the artist wanted people to make the connection between sewage and water. You know, our ability to move, contain, treat sewage improves our water quality.
Along with the art, another unique feature is the windows that allow the public to see into the building.
Some of our buildings are camouflaged to look like a house or a place of business or something that you wouldn't think what was going on inside of there, where this facility, one of the concepts was that people would be able to know that this was a pump station and what it was doing.
In October of 2008, years of planning and consultation paid off.
Very good. So, on behalf of Metro Vancouver and all the money we spent on this pump, I officially declare it on. And there's it running. The bell's ringing and it's running. We're in business.
This new pump station will handle the area's sewage for 50 years, pumping directly to the Iona wastewater treatment plant, instead of over to another pump station as it used to. That means more capacity for the harbor pump station and fewer chances of overflows in heavy rain conditions.
We're right here, right where the peninsula pinches down at the foot of Columbia Street.
Planning this project with the public's help is a new achievement for Metro Vancouver, one that has already changed the organization's way of doing business.
I think that the amount of public consultation and what we learned through that whole process was a learning experience for Metro Vancouver. Now we would be reaching out for the community and advising them and notifying them what we're planning to do. We're proactive rather than being reactive. People are more aware nowadays of what's going on in their community and they're more active.
Welcome back to the Sustainable Region and our look at managing liquid waste here in Metro Vancouver. Frying bacon. For many families, a real treat served on a weekend morning. But the grease it creates is bad news for our sewer system. Never pour grease of any type down the drain. It can clog pipes and cause sewer overflows. Thanks. Well, households do contribute, but the vast majority of grease in our pipes comes from restaurants and other commercial kitchens. Orange traffic barriers are the first sign that something is going on under the streets of Metro Vancouver. Workers are using heavy equipment as they move slowly from manhole to manhole. But just what are they doing? The answer is simple enough. The sewer lines that handle our flushes also get a regular flushing themselves.
A lot of grease accumulates in these lines from the restaurants down the street here.
A hose is fed into a sewer access point where high-pressure water is used to clean the pipe's walls. A camera goes into the sewer from the upstream end to follow what's called the flushing hose on its return journey. Maintenance workers use video imaging from the camera to look for trouble spots.
We know the hot spots, the trouble areas, and this has been known to be one of them.
44.7 meters of grease, photo 2.
What this engineer is talking about is grease. The white parts that you see in the sewer pipe are hardened grease, mostly from commercial kitchens.
If you leave it alone, then there's the potential for the grease to build up to become a grease blockage. And then when you have a heavy rainstorm, you could have the sewer back up and overflow.
The Marsh End Pumping Station is one of more than 500 facilities operated by Metro Vancouver that pump sewage uphill until gravity sends it to the closest treatment plant. Here too, grease is what they're targeting in the station's wet well.
If it does sit for a while, it actually gets to the solidity almost of concrete. And it just builds up and builds up and builds up. And without regular washing of the wet well, that'll just keep on going and building up. And chunks will start breaking off, which can lodge in the pumps and just cause all sorts of havoc.
Commercial kitchens are part of the problem, but they can also be part of the solution with responsible management of the grease they inevitably produce. At this restaurant, the grease trap is pumped out by a trained professional at least once every 3 weeks, and much more often in the busy summer months.
Excuse me, gentlemen.
But not all restaurants are as diligent, so Metro Vancouver is proposing several changes to the regulations governing the operation and maintenance of kitchen grease traps.
We're looking at having people remove grease from the grease trap at least once per month. Also to have the grease trap fully pumped out 4 times per year, as well as keep maintenance records on hand for 2 years for us to view and inspect if necessary.
If you consider how many restaurants are out here, how much grease is utilized in the course of a day, if it's just going directly into our sewer systems or into our drainage of any sort, then we're going to see ultimate problems at the other end.
In an older restaurant, a grease trap might be located in the floor. In recent years, it's more likely to be found under a sink. Regardless, the grease that's collected can only go to one of Metro Vancouver's 5 wastewater treatment plants. At Iona, a special grease collection facility separates out the solids for incineration and uses the remaining grease to help make methane gas, which the plant uses for power. In this case, grease is actually useful, but elsewhere in the plant, it can really gum up the works. Ultimately, it's the taxpayers who are footing the bill for the $2 million Metro Vancouver spends annually to deal with grease in the sewer system. That's a cost that could decrease if these new regulations are put into place. A win for taxpayers' wallets and for the region's environment. That's all the time we have for today's episode. We hope you came away with a better understanding of our sewer system and the challenges that Metro Vancouver faces in managing it.
Let us know what you thought of today's show, or tell us what you'd like to see in a future episode. You can reach us at 604-436-6794 or email us at sustainableregion@metrovancouver.org.
For the Sustainable Region, I'm Dagmar Timmer.
And I'm Vanessa Timmer. Thanks for watching, and see you next time.